Hello guys, welcome once more to class online, to the physics class online, and my name is Tutor Dami. Now in this edition, if you ever have a problem with friction and you need a lot of clarity, this video will help push you forward beyond where you are, because we have two questions in frictions in this edition, and also we have a question on machine, so you might want to stick around. Now don't forget that if you learn something from this video, click on like button. We have a lot of content to send to you that will better help you clarify a lot in physics. Now let's get to number 11. From the diagram above, calculate the work done. Calculate the work done when the particle move from x meter to x equals 80 meter. That's x equals 0 meter to x equals 80 meter. Now this is a question on work, and this question is just a graph on work. Now, but this question is actually leaning on the formula for work. So this question can only be answered by the formula for work. And of course, you can see that this is force and this is distance here. So it is a force distance. You know, work is force times distance. So that means, but while we were taught that work is force times distance, we were also shown graph that it can be solved graphically. So the work in this question is simply the area of this shape. What shape is this? This is a triangle, right? So the area of this shape is the answer to the question. Now, first of all, I have to label that triangle out. Now, it is from 0 to 80 below. So it will become from 0 to 80 below. That is the triangle I have here. It's a triangle from 0 point to 80 points. And that is the one below. Then the vertical height is from 0 to 60. Is standing from down to 60 points. You can see this here is 50, is 60 here. The force here is 60 from 0 to 60, and the horizontal is from 0 to 80, because they even stated it from 0 to 80 m, and that is it. So this is the shape now. Now the work done is just the area of this triangle, and you know from primary school that the area of triangle is half base times height. So the half is just 1/2. Base is base, and this is my height. Now the base is the lower part here, 80, and the height is 60. That is standing straight up 60. So now I have to cut. 2 cut 80 is 40. Then 40 times 60 is 2,400 joules. And that is the simple answer to the simple question. And that is the end for number 11. Don't forget that work is force times distance. But if they give you a diagram, it is the area of that diagram. Number 12 says the diagram above shows a wooden block just above to slide down. That should be about to slide down an inclined plane whose inclination to the horizontal is OC. The coefficient of frictional force between the plane is what? Now, when you hear the word coefficient of friction, what would you do? The word coefficient of friction has a formula. Now, which of them is the formula for? Now, this is not a calculation. It's just to test if you know what is called coefficient of friction. Now, which of them do you think is used for finding coefficient of friction? Now, you must know that coefficient of friction is symbolized by this symbol, because the main formula for any question on coefficient of friction are just this. Now, it is naturally frictional force over reaction force, but it can also be found if it is angular. If there's an angle there, you will not have to do that. You can just do tan of the angle. The tan of the angle is the coefficient of friction, and that is the answer. So coefficient of friction is given by two formulas. It is either F over R, which is frictional force over reaction force, or tan theta. And those are the two formulas for finding the coefficient of friction. Now this question is on friction, and that is just the answer. The answer is tan theta. Number 13, an object of mass 20 kilograms slide down an inclined plane at an angle 30 degrees to the horizontal. The coefficient of friction is what? The coefficient of static friction is what? Now, generally, we've done it before. We've said before that coefficient of friction is tan theta. It has been stated before, and this is now the application of it now. So now I will not have to use this 20 gram, because I have been given theta. So I'll just plug in my theta to tan and get my answer, and that's just all. So the coefficient of friction is just tan 30, and that becomes 0.577 approximately to 1 decimal place, 0.6, and that is just the simple easy question. Now, but if you were given the frictional force or the reaction, you can use these two to find the coefficient of friction, and they can ask you backward or forward. But generally, if you were ever given an angle, any angle, in that question. Don't stress yourself. Just do tan of the angle, and that will give you your coefficient of friction straight up. And that is just it. So it depends on the question. So, but this clarifies the coefficient of friction. And please don't forget, I believe that this is the strongest formula in friction. This coefficient of friction equals frictional force over reaction. They can ask you for the frictional force and give you this one and give you this one, or they can ask for this and give you any of them. But if you know this question, this formula, you can answer a lot of questions in friction. Most of your problem in friction is 60% solved, and that is just it. Now let's go to number 14 now. So the answer for number 13 is D. 14 says a block and tackle is used to raise a load of 250 Newton through a vertical distance of 30 meters. What is the efficiency of a system if the work done against friction is 1,500 joule? Now, for efficiency of a machine, it is work output over work input times 100. Now, what is the work output? We were told here that it is 5. No, work is force times distance. So it went through 250 Newton across 30-meter distance. That will become load times distance over the work output is the work in plus the frictional force. So even what I wrote here is not, it is supposed to be the work input. The total work output is the work input plus the frictional force. Now this is my work output here, load times distance. Now my work input is the same work, my work input is the same work output plus the frictional force. Now can you see this now? 250 times 30 over the same work output here, 250 times 30 plus the frictional force, 1,500 times 100. That will give 250 times 30 is 7,500 over the work output again, 7,500 plus frictional force, 1,500, and that will give me 7,500 over 9,000 times 100. 0 cancel 0. If you cut this, you'll be left with 7,500 over 90, and that will give you 33.3%. And that is the answer for that question. Don't forget that for the efficiency of a machine, it is work output over work input times 100. And work output can be given. Work input is work output plus frictional force. And that is the big lesson here. Don't forget. It's very, very important that you remember that. Although efficiency of machine is generally given by a mechanical advantage over velocity ratio times 100, but it can also be work output over work input times 100. So it can take two forms. One, MA, mechanical advantage over VR, velocity ratio times 100. Two, work output over work input times 100. So either of them can help you find the efficiency of a machine. And hardly I have been going through past questions, I've seen that efficiency of machine is always been asked. Is always in Jamb. They always ask questions around efficiency of machine. So please take time to go through it again and again, and make sure that what was explained here is clearly understood. I emphasize that you might be asked, and the tendency of you being asked is very high. So please, it is one of the most important parts of physics that you can't afford to forget, and that is number 14. Number 15 now says if a load of 1 kilogram stretches a cord by 1.2 centimeter, what is the force constant of the cord? Now when you hear the word load stretching, that is elasticity. The word stretch told me that this is an elasticity question, right? Now how do you find force constant? You must know that from the Hooke's law, it says that the Hooke's law says that what the force acting on an elastic material is directly proportional to the extension on the material, provided that the elastic limit is not exceeded. And that is Hooke's law. The force, it is just by this formula. When I see this formula, I will remember the law. It is that simple. And that's the way I break down laws. I break them down into formulas. Force is directly proportional to extension, provided that the elastic limit is not exceeded. Okay. Now, if I solve for that, I'll be getting elastic constant K. And that will give me, this proportionality will become equals to Ke. Therefore, your K will now become F over this E will come from here and come under the F. So K will now become K equals F over E. Where now we are told to find the elastic constant, and we have been given the force and the E and the extension. So my force is now going to become 1 times 10, because from the question I have 1 kilogram for my force. No, force is mass times G. mass times acceleration due to gravity. So the mass here is 1 and the acceleration due to gravity is 10. Okay, then that's the force over the extension given to me is 1.2, but you must change it to millimeter, and that will become 1.2 centimeter. You must change it to meter, and that will become 1.2 times 10 to the power minus 2, because to change from centimeter to meter you must divide by 100, and that is 1.2 times 10 to the power minus 2, and that is what you get. You will have there. So what is up here is 10. It's just 1 times 10 is still 10. So this 10 to the power minus 2 will go up, and that will become, it will change from minus 2 to 2. 10 times 10 to the power 2. Okay, so the minus is gone because it has gone up. So that will give me 1000 over 1.2. The force constant will become 833.3, and that is the answer to that question. Don't forget that everything came from the Hooke's law. Force is directly proportional to extension, provided that the elastic limit is not exceeded. Okay, and then from there you will create the force constant K, and then when you put force over extension, you will put your parameters in and get answer. And please don't forget that force is mass times what? G, where I must change 1.2 centimeter to meter by multiplying by 10 raised to the power minus 2, and that is how you will get 833.3, and that is the answer for force constant. That is the answer for my 15, and that brings us to the end of this section. Don't forget that if you learn something from this series and you want to get more content from us that will better help you understand physics, click on like button and we'll get to reach you with more content that will clarify so much for you in physics. Until we see you guys, take care of yourself and bye for now.